All right, guys, so we're continuing on with 2, 3, 1 notes. We got about halfway through it last week, and we're going to finish it up today. And what we did last week was we were given the equation, then we needed to find the vertex, focus, directrix, and axis of symmetry. This time we're going to be given two pieces of information, either the vertex, focus, vertex, directrix. Two pieces of information, we need to find the equation. And to do that, we need to find the values of h, k, and p, as well as which one of the two equations it is. Now, when we look at the first one here, we want to write the equation of the parabola. Now, they tell us the vertex is this point here, which is the point 0, 0. And the directrix is given to us in the equation, and it's actually the equation y equals 3. Now again, to find the equation, we do need to find the values of h, k, and p. Now luckily for us here, they did give us the graph of the equation. And since it is opening down, the equation that we'll be using is our y equals 1 over 4p times x minus h squared plus k. The other way we could have gotten to know or understood that this was the equation we needed was from the directrix, because the directrix is y equals. And there's only one of the two general forms that has a directrix of y equals, and that's this one here, our y equals 1 over 4p times x minus h squared plus k. So we have this here. Now the vertex is still in the general form, our point h comma k. And for this one here, the h value is, and the k value is 0. So really the only thing we need to find at this point is the value of p. And according to the general form, this is y is equal to k minus p. Now according to our formula, k minus p is equal to 3, because k minus p, if we plug in the values of k and p into the equation, we get a value of 3. Now we know what the k value is. It is 0. So we can plug it in for k, and now we just need to solve for the value of p. Well, 0 minus p is just negative p, is equal to 3. Now we do need to find out what the value of positive p is, so we'll divide both sides by negative 1. Negative p divided by negative 1 is p, and 3 divided by negative 1 is negative 3. Questions on how we found h, k, or p? Because that's our general form for the directrix of this equation. Because we're setting it up so that we can solve for the value of p. Because y equals 3 is our directrix for this one here. The general form for it is y equals k minus p. So that means our k minus p, when k and p are plugged in, should give us a value of 3. Any other questions? What? No. Now we need to plug in the values of h, k, and p. So we'll get 1 over 4 times negative 3 times x minus our h value, which is 0, plus our k value. So the first thing we need to simplify is our 1 over 4 times negative 3. And if we plug that in, we get negative 1/12. Well, our x minus 0 squared is just going to reduce to x squared, because x minus 0 is the same as just x. And if we square x, we get x squared. We don't have to put the plus 0 because it doesn't add anything. Because we can put parentheses. These would be the same. But since the number in front of x is just 1, and if we square it, we're still at 1, so it's just the same. Questions on this here? We're ready to look at the next one. Just write an equation. We're just having to write an equation for these here. If it had asked for the vertex, focus, directrix, and axis of symmetry, then we would. Here, it's just wanting the equation. Because we did that rest of that on Friday. Now again, it wants us to write an equation of the parabola. Now the vertex is given to us by the point 0, 0. Now again, because it's opening up, our general form of this equation is our y equals 1 over 4p times x minus h squared plus k. And again, just like before, we need to know the value of h, k, and p. And the vertex is still our point h comma k. So the value of h is, value of k is 0. Now our directrix, if we look at the general form, y is equal to k minus p. So matching that up to the general form of this equation is y equals k minus p. So what it's telling us is that our k minus p value should be negative 2.5. If we plug in the values of k and p into this equation, we should get negative 2.5. Now we already know what the value of k is. K is, so we're saying 0 minus p is negative. Well, 0 minus p is negative p is equal to negative 2.5. Right, we can multiply or divide by negative 1, telling us p is 2.5. Questions on how we found the values of h, k, and p? Now we can plug our values of h, k, and p back into the equation. So we'll plug 2.5 into p, 0 for h, and 0 for k. Now the first thing we can do is 1 over our 4 times 2.5. Which gives us 0.1, or we can write it as 1/10. I'm going to write it as a fraction, but either way works. Now again, just like with the last one, we have x minus 0 squared. It actually just simplifies to x squared, and that's it. Questions on this here? We ready for the next one? Now this one here did not give us a graph, but if we look back at the directrix, for the first one, our y equals, directrix is the equation y equals. If we look at the other equation, the directrix is x equals h minus p. So this does have x equals, which means the other side is h minus p. So our general form for this equation here is our x equals 1 over 4p times y minus k squared plus h. And for any of these here, we still need to know the value of h, k, and p. And we do have a way to solve for the value of p, because that'd be h minus p is equal to negative 3. Now, what are the values of h and k? How do we know they're 0, 0? because it's told to us in the instructions the vertex is at 0, 0. It didn't say it next to the directrix, but it did say it in the instructions, so the h and k are still 0. So if I plug it in, we'll say 0 minus p is negative 3, or negative p is negative 3. Minus p is 3. Now again, the section 2.31 notes does have different forms on the first page that we could do this, because it does say for the directrix on there that x equals negative p instead of h minus p. And the reason for that is because they already plugged in the values for h into the form. They already plugged in h and k as 0. I think it's better to do it this way. It does provide a few more steps. But the method that we're using for this, the steps we're using for this here, works if h and k are 0 or if they're not. The ones that are in this note sheet, x equals negative p, only works if the vertex is 0, 0. If it's not, then we have to use the other method. Why not use the one that works for all instead of just trying to pick which one works best for each one? Now that we have the values of h, k, and p, we can plug them in. 1 over 4 times 3 times y minus 0 squared plus 0. Now the first thing we can do is our 1 over 4 times 3, which actually works out to be 1/12. Now if the value of h, or here the value of k, was something different than 0, we would leave the parentheses squared. But since it's not, we have y squared. We don't include the plus 0 because it doesn't add anything, and we get this here. Questions on any of this here so far? Let's look at the next one. Well, the vertex is still the point, 0, 0. It is our h comma k. Well, I already know what the value of h and k are. They are both 0. So looking at the focus, well, y value in both places is still 0. So we can say in the general form the y spot should just be k, because it's going to be the same. Since it's k in the vertex, it has to be k in the focus. The x value of the vertex is 0. X value for the focus is negative 2. We're adding something to it, which means we have our h plus p comma k. Because that x spot, we're adding a value to it from the vertex to the focus. Huh? Right, because if we look back at the general form, h plus p comma k would be our x equals. So we'd have x equals 1 over 4p times y minus k squared plus h. And exactly. Because if we went through and solved, h plus p would be negative 2. We would plug 0 in for h. 0 plus p is the same as just p, and it tells us p is negative 2. And at this point here, we can plug it back in. Now we do need to simplify our 1 over 4 times negative 2. Which is negative 1/8. Since we have y minus 0 squared, it's just going to simplify to y squared. Our plus 0 we don't have to include, because the plus 0 is not adding anything, so we're left with this here. Questions on this here? Hopefully notice with any of these here, really once we find the values of h, k, and p, it flows and follows pretty simply from there. Well, h is still 0. K is still 0. We just need to find the value of p. It would indeed be y equals. And the general form would be h comma k plus p. So in our case here, k plus p would be 3/2. So 0 plus 3 is 3/2. Direct 6. Because if we look at the two forms for vertex, or it's not vertex, focus, it's either h comma k plus p or h plus p comma k. So the value of p, depending on it, it doesn't change from there. But the direct 6 k minus p, direct x h minus p. Because in those cases, we have the opposite of p technically, once we get it by itself. But here, well, here we have k plus p equals 3/2. 0 plus p is 3/2, or p is 3/2. So we do need to simplify our 1 over 4 times 3/2. It actually works out to be 1/6. Questions on this here? How do we feel about this so far? Are you ready for the next one? That's it. And that is it with 1 or 2.3. We are completely done with 2.3, which means we're moving on to 2.4 next.